For this problem, we are asked to sketch the graph of the function g of x equals f of negative 2 times x minus 1, and to clearly label the coordinates of the new locations of points A and B. And I'm just going to add a third point here. Whoop. Here we go. Third point here, and that's going to be point C, and that's 2, 0. And that'll just help us to graph the function more precisely. What I like to do is to take something like this and to break it down into each step based on order of operations. So the first thing that we're going to look at here is the multiplying 2 times x. For us, this means that it's going to be a horizontal stretch or compression since the 2 is directly on the x in parentheses. Since 2, which we call c, is greater than 1, this is going to be a horizontal compression. And there's a little tool that is very helpful to me in doing horizontal stretch or compression, and that is to take any point x, y, and since the 2 is in the parentheses and not being multiplied by, or not multiplying the entire function, we can go ahead and do x divided by c, y as our new point. And if this 2 was outside of the parentheses or, applied on the whole function, then we could go x, comma, y times c to change the shape of our graph as well. So we're going to compress by a factor of 2. So we go ahead and we start with our points, 0, 3, 2, 0, 4, 3, and we do an x divided by c. So we're still going to have 0, 3 here. Here we've got 2 divided by 2 is 1, 0. And 4 divided by 2 is 2 and 3. We'll go up here and we'll draw our new points. This stays the same. 1, 0, 2, 3. And it's easy to see here now that the graph or function was compressed horizontally by a factor of 2. Our next step is to look at the negative that is on this function, and negative x is going to give us y-axis reflection, and if the negative was outside of the parentheses affecting the whole function, then we would have x-axis reflection. Essentially, this is going to change our x value, and it's going to make it opposite of what it was. So 0, 3, again, stays as 0, 3. 1, 0 goes to negative 1, 0, and 2, 3 goes to negative 2, 3. And we can go ahead and graph this again. Negative 1, 0, and negative 2, 3 is up here. And now we've created our y-axis reflection. The next step, and the final step, is to apply this minus 1 that is applied to the whole function. This means that we're going to be moving the graph down 1. If it was a plus 1, we'd be moving it up 1. So that's simple enough. Down 1. So we're going to be changing our y values, and we're going to be subtracting 1 from them. So 0, 2, negative 1, negative 1, negative 2, 2. And now we go ahead and plot these new points. So 0, 2, you can see that it's moved down 1. We have negative 1, negative 1, negative 2, and 2 is up here. And we have our final graph. And that would be the solution. I guess we could label the coordinates as well. 0, 2, and negative 2, 2. And if we wanted, we could do negative 1, negative 1.